Hey everybody, Mr. Berry here. I want to take a look at this absolute value function here, and I'm just going to think about picking out as much information from this as possible. I'm not really worried about what the equation or function looks like right now, just trying to pinpoint certain locations. The first one I should see here, anytime I find an absolute value, I believe it's the easiest thing to figure out would be where the vertex is located. And right here, we can see where that V, it's actually an upside down V, where that V is located. That point right there would be a point value x comma y. So we go over to the left, 1, 2, 3, 4, and then we go up 1, 2, 3, 4. So for a point, we went to the left 4, it would be -4 for x, and for our y value we went up 4. The y value here would be +4. We can see that this graph is going downwards. So when it comes to the range and when it comes to the vertex, we need to consider what just happened when we figured out the vertex and how the graph appears. The first thing I would say is that since this graph is going downwards, this point right here, the vertex, is the highest point on the graph. Since that vertex is the highest point on the graph, that vertex is going to represent a maximum location. So again, in this situation, this is a maximum location. What that means for us is that when we go ahead and we dictate what the domain and the range would be, especially the range in this situation, we know that we're going to have points that are below that location, but no points on this graph go above that location. So here in this situation, the range is a y value. Our y value, that's the tallest point here, is 4. Everything below it, nothing above it. So our range would be y is less than or equal to 4. We got a 4, a 3, a 2, a 1, a 0, so on and so forth, but nothing above it. As we've mentioned in previous examples, domain very much all the time for us here on these absolute values will be a negative infinity to positive infinity situation. This arrow down here is going to go off to the left forever. This arrow right here is going to go to the right forever. So our domain, as you're going to see quite frequently, is that negative infinity is less than x is at positive infinity. Something you're going to see a lot here. Other information we can point out from the vertex is the axis of symmetry. And I just drew in a dotted line, and it's not a part of the absolute value. But if I needed to label that axis of symmetry right here, the axis of symmetry, you might have noticed or thought to yourself, is it's actually a vertical line. And we know vertical lines have a equation of x is equal to something, and no matter where I travel on this imaginary mirror, my x value has to be -4. So here in this problem, our axis of symmetry is located at the spot x is equal to -4. No matter where I travel on that imaginary mirror, it would be x is equal to -4. From that mirror to the right, I just want to point this out to you real quick, we can go ahead and check the slope out for this line off to the right. And you might have said to yourself, every single time if I start at the vertex, I go down 2 and to the right 1, down 2 and to the right 1, down 2 and to the right 1, down 2 and to the right 1. Sorry about that. So off to the right here, I have a slope. I'm going to use lowercase m for a second here. The slope here is going to be -2. Off to the right, again, this is a mirror, so we should have something that's kind of similar to that. Off to the left will be a slope of +2, because as I work my way up here, you can see the lines going upwards. I go up 2, right 1, up 2, right 1, up 2, right 1. We're going to really focus in on the one to the right side. and we'll talk about that in later videos. But it's good to see here that our slope over here all to the right of the mirror is -2, and our slope to the left of the mirror is +2. And you'll see that pattern continue as we go along, that they almost mirror each other, one of them being positive and one of them being negative.